Welcome to CodehubIndia. Yesterday we learned heat and transfer. In these classes, we will learn about the gas processes, its curves name, in what basis the gas, the PV ratio are changing with different type of process of gas. And the heat transport. What Pascal Thomas told in the earlier classes, we have told you the change in internal energy the heat inside that system minus work done. The work done may be indoor or exo, that heat transfer from your system to outside or heat transfer from outside to system. The heat quantity, the flow of the system, that minus Q flow out and plus Q is the flow into the system inward. Work done, the system to the work done, that is W. And when the work done is done by the surroundings of the control volume, that is minus W. The system have given the work to the surrounding. Surroundings of changes took place. This type of that work done is done to two types, that plus W, minus W, and the heat transfer heat flow is two types, plus Q, minus Q. And depending upon that value, we are getting the change in internal energy that we have learned earlier classes. Don't have anything more to say, and we have learned also that the PV equal to constant. The isothermal gas line graph looking like this. This is the isothermal graph line. PV gas. When we increase the power, we will understand in advanced courses. The P the power 1 minus gamma, that is properties I told you. Okay. So you have gone through earlier classes all. The internal energy stays the same. If gas moves along an isothermal PV equal to constant, this internal energy stays in the same. If the heat is exchanged or work done, the gas state variable trace a path of PV plane, that is isothermal. Okay, the two variable is what? P and V on the plane. The P in the y-axis, V on the x-axis. This is the y-axis P and x-axis V. So, let us consider, I told you in previous classes, all the classes, about the piston movement inside a cylinder. This is piston DL. Okay, and the area. And you know what is work done by mechanical, that we know force into displacement. Okay, what is displacement? What you know about the force according to pressure? What is called pressure? Pressure is pressure, I told you earlier classes. Okay, force acting point area. Okay, then what is force? Force is equal to PA. Okay, and the force into displacement is what? Force into this is force into displacement. What is the displacement? That is a DL. Previously it was here. Okay, previously it was here. Okay, or after displacement of this, it is here. This length is how much? It is DL. Okay, then work done is DL. DL distance travel, force acting in the distance of DL, that is equal to work that is given here. Clear? And that is what? By gas, PV is the work done, say volume change with the displacement of piston downward, compressing the gas inside here with the length of dl. Then the PV is the what? Change in volume is the work done. What is change in volume? Suppose volume was previously P into say V1 tha, okay. Now it changed to V2, okay, and V1 was V2 equal to del V. Clear? That is equal to dV, and that value as per the isothermal expansion was PV equal to nRT. You know that is the PV. This is the nRT. Okay, divided by D. Okay, this dV is here. No problem. That we got that the log value V minus A. Okay, I will make it clear in the maths class about the log. Again, the second level of the foundation course will be started. This is the first level, and in the first level of mathematics you will learn the log, and in the second level of physics you will get again some elaborate little bit. So it is clear to you. We discussed earlier classes also. Now that we got this formula isothermal, that curve is like this, and this is the work done, change in volume. Okay, this is the area. You calculate this area, then it is called work. Okay, it's just an area under the path. That is called what? Work. So integration, you will learn how to calculate the area in 2 dimensions. Okay, this is the most vital part. Integration you will learn. Okay, so gas clearly does less work going from A to B on the red path. This means less gas heat is supplied to the gas along the red path. If we drop like this, then due to some reason that gas will, if we consider this area, I mean to say this area, then work done will be less. How much? Total W minus this area. Okay, clear? So how to calculate the area we will learn in the integration chapter of the mathematics. You will calculate the whole area. Okay, then calculate this area, and then calculate this area. Okay, this area equal to total area minus this area. Okay, little bit less area, the red part, but let me try. There is a property will arise, the mole of the ideal gas Cv, a constant Cv. That I told. What is Cv? Cv is the heat required to rise a 1 degree centigrade of that material. Okay, of 1 gram at constant volume. Then C will converted to Cv. Okay, clear? That means what? If indoors or exo, heat required or heat given off, okay, of that heat capacity at constant volume. Molar heat of ideal gas. Recall that internal energy of a molar gas you have calculated, that was 3 by 2 MAKT, 3 by 2 RT. Okay, and therefore the heat energy into the rise of temperature, what is a constant volume. The constant value Cv is given by, you have to keep it in your mind. Cv equal to 3 by 2 R. This for the ideal case. Okay. Where R is the universal constant, you know. Clear? In further classes, we will know what is the ratio of the value of the CV by Cp. What is Cp? Cp is at constant pressure to increase the material required heat or supplied heat to rise in temperature of 1 degree of mass of that material 1 gram. That heat called at constant pressure. That is called Cp. Then Cv by Cp equal to gamma. That we will learn all the things in this class. Going ahead. Now there is Cp variety. So to define Cp, it's not at all problem. We have defined Cv, and Cv we know this is the Cv value. Okay, and change in when the change in volume of that equation, the change in temperature. Do you agree with that? The directly proportional. Okay. Temperature increases 1 is centigrade equivalent to 1 K. This equation work done expanding the pressure of the this equal to this, because this del T become 1. Okay. Then P del V for 1 degree of R joules equal to how much? C equal to Cp equal to Cv plus R. We put the value of that thing, because if I put the value of Cv here, then R will common, then 3 by 2 plus 1 equal to 5 by 2. Understand? 3 by 2 plus 1 equal to 5 by 2. 2 equal to 5 by 2. Clear? So the Cv becomes the 5 by 2 R for the diatomic. What are the things the diatomic? What are the things the monoatomic? The valency. Diatomic, the valency. Di means 2, mono means 1, tri means 3, penta means 5. Okay. So this is the one valency, so it is called monoatomic. For the monoatomic, Cv equal to 3 by 2 and Cp equal to Cv plus R. Okay. For the diatomic, what are the diatomic? O2 say diatomic. Okay. The Cv equal to 5 by 2 R. And Cp equal to 0 is the visual, the diatomic molecule at little dumbbell flying around. When two collide, they extend and they spinning. They are spinning 2 times, spinning like 2 like this, and it is spinning on this axis. Okay. So you can show the applying Newton's law of collision that average spinning motion will have equal to that of that equipartition energy link. Let us move the degree of freedom. It is a matter of mathematics. We will learn with the mathematics. But if you see the in the common sense that in your family, how are the controller of you? In your family, your mother is controller, your father is controller, or your uncle is controller. Suppose you have no uncle, then your freedom right of 1. Total controller is restricted to 3. Now no uncle, you have 2 controllers, then your degree of freedom how much? 1. Uncle is not there. Uncle is not influencing the factor. That you are not having the degree of freedom in common sense, but in mathematics you will understand in mathematically what is called degree of freedom. You will understand here a little bit, because you see the if you're going to learn the physics, chemistry, then math is the relevant, everything should go in parallel, and one time you cannot cover it. Required all to synchronize all the idea and thought. So monoatomic gas, we say that atom have a 3 degree of freedom. Diatomic has the steric heat is 80, only there is a 2 more degree of freedom. Diatomic have how much? 2 degree of freedom. And bigger molecule have any more possibilities, variable energy. That means what? Monoatomic have everywhere to go. Freedom means what? Three. But monoatomic have degree of freedom have 2. Diatomic. Obviously that 2 are perpendicular. If you could draw the orbital tree, the oxygen will play like this. Here is the nucleus, here is the nucleus. Okay? Then it will try to this, go, pull it out and pull it out. When dissociate, it will break, and it will become nascent box. Oh. So it is clear now. So equivalent puzzle, the specific hydrogen of a function of T is like this. Okay. There is a temperature. And the PV equal to nRT, where n is 1. N equal to 1. And T equal to T equal 1. Then PV equal to this condition. Okay. Model getting here same is like this. At low temperature it should act like a monoatomic. No thermal energy is going to increase and rotational. Even for the molecule are colliding. The vibration mode is clicking in at this stage. At this stage, rotational mode means what? At this stage, rotational. It is what? Rotational and vibration. And this is what stage? At low temperature. Temperature sign. Low temperature. High. Okay. These are 3 temperature difference of the degree of freedom. Freedom 1, 2, 3. Okay. Of temperature. So it is rotation as well as speed. Okay. Vibration I can say. This is rotation only. This is what happened is steady because at low temperature is to monoatomic gas, no thermal energy is going to rotational mode. It is steady. If they are colliding, it is steady. I am pushing you at low pressure. You are so stable, you are not pushing back, you are not on self thrown out back. At high degree of freedom when I push you, or the value of T more than 1, then what? Degree of freedom 2, then we will little bit sack. At degree of freedom 3, you will fall down. Okay? Clear? In basic concept. So molar specific heat of a solid. A solid has such that element can picture as a crystal structure. Okay? You can say graphite, carbon, okay? Like this. Matte like this. Graphic like this. And each atom acts like a oscillator. It is oscillate like this. Okay. With time to wait. This side is amplitude. This is the time or theta angle of rotation. And getting the kinetic potential energy will add the total energy to what? If kinetic energy will increase, potential energy will decrease to keep the equation. Okay? As you know, the law of conservation of energy. We cannot create, we cannot destroy. When kinetic increase, the potential decrease. When potential increase, kinetic decrease. It looks like that if I say that this is a car, so it should like the okay, not here. This is not here. Okay, this is not here. Let us stop here. At the car, it is decreased. There is no any hard and fast. You just think that we cannot create energy. We can transfer the energy. Law of conservation of mass and energy, you know very well from your childhood. So each atom acts like a oscillation with the 3 degrees of freedom. If we model it this like the cube, like if we take a cube like. Okay, then here we also one atom. Okay, okay, here we one atom. Okay, this line will join. So dotted with the finger. So if we pull it up like this, okay, here will a line also this. The given atom, here will be atom. Okay. We join these, we will atom. So what is the degree of freedom that all atom can go to all sides. Okay, all sides means what? This is the X, Y and Z. Okay, all sides can go. How much? 1, 2, 3. Okay. Every that this one can move this direction, this direction. Okay. So degree of both kinetic energy suggesting to molar specific heat. That's 3R. Or this degree of freedom 3. So what it was told earlier? 3.5R. That's 3R. Okay. This is just the long static value and the work with many elements. So that curve arrives. Molar specific heat of a copper and diamond. Almost all the elements are like a copper. It follow this specific heat formula like this for metal. but diameter is quite different. It's like this. Okay. Diamond is like this. Diamond. Okay. Okay. Diamond is steel. The copper. Okay. Yeah, graphite. Different type of diamond are there. We will learn chemistry. Einstein solved that puzzle. Einstein assumed each atom has a basically 3D mass, just like a spring oscillation I told you. And different with the diamond with mass are quite small. Carbon and spring are very strong. In carbon, hardness is very strong. Its melting point is how? 3000, 2500, 3500, depending on type of the carbon. It's hard, so this means the oscillation have a very high frequency. Okay? And the suggested like the rotation, their oscillators could only absorb the energy in chunks, called the quanta. When they oscillate, it absorbs the energy with a packet of energy. That's the quanta. And one chunk is omega. Okay. Well, H is what? As a rotator. Understand? So these are the parameters we have defined. That means the higher frequency diamond oscillators could only absorb energy at bigger chunks because it's very strong. Therefore the higher the bond is very strong. Totally insulated. Therefore, the flow of that, if I consider So what becomes the gamma value because it becomes here. What is gamma value? Means adiabatic has this certain thing when the power is increased, the pressure is increased. When the pressure is increased, okay, the volume is increased. Volume is increased. So the rate of adiabatic rate that the volume is moving towards the volume side. The volume side. Water to understand which goes here. Don't think as big. That's why the caloric fuel is not very big. We calculate the fuel was a fluid and liquid. Where is that line? Down what? By the time rate of temperature rate of time that is called radian. So this is the time. Okay, and this is the time that by rate of change of x equal to radian. Okay. Proportional to the cross section area. In more area of the conduction, the heat flow will move. Water is going more water, more heat, no problem. And having natural network that comes from the electric environment and what? There is
what is the rate of change of heat, change of heat, change of time. What? Time. The rate of change of heat. What is the velocity? Rate of change of by time. Okay? Velocity. What is acceleration? Rate equal to rate of change of velocity. Small v del v divided by del rate of the velocity per unit time. So the distance per unit time. So velocity of the heading rate of change of q per unit time. And that thing will be what? That is what? That is the it's a total length, okay? If you consider the small section of, say, what is the heat transfer? Rate of change of heat transfer here, and this, that is dx, okay? The small x of the L, okay? And that is dx. That is what? Dx. Okay, what is dx? The change of temperature here from here to here, change of temperature. Okay, that is here. That is small of the L part, that is dx, and that is the got it. The heat conduction and also the microscopic view of the heat conduction. If 1 unit of the metallic rod is heated and atom near that it hydrates more vigorously. Understand? What are the metal we are getting from the earth? This is not good. We are not getting aluminum pure. We are not getting copper pure. We are filtering it by different components, and we are making a process with different process there to make the proper iron. But we cannot really, because that all are coming with a compound from the earth. We are taking out the ore with a compound where the majority portion is iron. The ore of the iron. Right? Very important is iron. Different process to filter out the iron, but that process is not so pure. You will get the pure one.
embedding here some other metal also a small quantity, that is called impurities. That is not uniform in strength towards this length. The bond is not equal per unit length of the strain is not equal everywhere due to these impurities. You know very well the heating is the coefficient expansion, and there is an impurity here. Coefficient expansion is maybe less or more, and the iron may be less and more as compared to both, and there is twisting took place, the thermal took place. And that is called lattice effect. What is called lattice effect? You can say the lattice, you get the lattice. And then that is the energy, the bond energy, the bond density, and that is not due to the impurities there. No metallurgical science have so up to date to make free from impurities in any particular metal. That's it. Okay. So actually it is diffused down to the rod, and molecule has a gas, and the comparable time they move at the similar speed of the molecule, and many solids have measured the part of the hundred of the atom. The heat conduction is what? We can just pull up this free electron. The metal or shiny material or conduct electricity well. Which conductivity is well in heat, and electricity is also well, but not all the cases. It depends upon the position of the periodic table of the element. That I am not going to explain you right now, okay? But in general concept that the electricity conduct electricity well means what? The process of cold treatment, when you rub that knife, anything sharp, okay, to make it sharp, to make it shiny, that's called cold treatment, okay? You are rubbing with the hand pauses, and the surface hardness increase, and when surface hardness increase, it's looking like a shining. Clear? The knife is looking shining after rubbing. That means you have cold process there with rubbing on the stones and floor, anywhere you like, to make it smooth. And that means what? It generates free electrons and conductivity is more. The simple is the electronic process, and the free electron is the valence bond at the outer orbit, the free electron outer orbit, the free electron outer orbit, the remaining part required, carbon 4 is required to make it stable. The free electron is what? The electron 4 is moving in the valence band. Okay, I am not going to discuss it right now. Okay, and the conduction band. Okay, the heat flow, electron flow. We will discuss later in electricity and atomic physics. So electron not bound to individual atom, but free to move through the material. Electron moving in the cloud. Okay. So the electron are excellent conductor of heat. They move very fast and having long mean-free value. The metal typically conduct heat 100 times better than the non-metal. Clear? Most of the transition element at the center, is a transition element, okay, in periodic table. This is transition element at the center. Okay, at the center of that element, most are conducting. Okay, the center all the elements are conducting, more conducting. Okay, but it's not, you can say, generalize the theorem this for the all elements. There is a special exclusion also there due to F orbital. This is the advanced orbital theory. Lot of regions are skinning effects are there. So heat insulator, you know that I told the Rockwell insulation. Rockwell is the very hard diamond. Density 12% that of the water and it is able to clean it. Okay, and poor conductor of heat. So you can insulate this. In the big turbine we will use the lead also, PV. Okay, the turbine, you know, turbine is used for the hydroelectric project. Okay, and steam heat thermal power plant. There is a turbine. We are having a boiler. Okay, this is a boiler. That container water. It is boiling, making the super saturated steam. Okay, and steam is going through there, and in the turbine there is a plate. Okay, the steam is allowed to flow inside the turbine. Okay, and plate, hand plate, you know, when the high speed super saturated steam is knocked, you knock on the plate inside. It is so, after the shape, the plate is so safe that just like a blade of fan is safe, no? So turbine is so safe that turbine will rotate. This mechanical energy is coupled with the generator. Okay, and the electricity, okay, and the electricity is transferred to the high tension line. Okay, that high tension line, you have seen the big wire, no, in the farm field. Okay, agriculture field in a village. So these holes are too small to convection of the current. What are things? The electrons, we are thinking the what energy of electron. If it is the same energy of photon, and this is a proton. Okay, and electron is and photon can be a hole. So this is a hole. This hole. Okay. This is the hole of the photon, and electron are coming here. Again, this electron will jump from this hole. Okay, and this nucleus will come. This will jump this hole, and this will jump like this. Okay, if this one will jump this hole, this will jump from. There is a propagation of hole. Electron moving right side if we consider the hole moving left side, right, keeping the hole on the left side. This is the analogy. Okay, you think that polyethylene are the even better heat insulator. The polyvinyl, polyethylene, the PU, polyethylene, what called PU. We are using paint tube. Paint, what is paint? Paint is insulating material. Okay, insulating paint is insulating material. Okay, because we are in problem with the iron, the rust, and the wall with damp. Okay, we do paint on the wall to protect the wall from the damping. That is non-conducting material. The paint is what? Non-conducting material, so that if outside atmosphere moisture will not attack to go inside, make a water gallery inside the wall, or the atmosphere with the oil painted on the iron grill, it is insulated to make a contact with the outside water with the iron to make a ferric oxide.
So PU is used. There is a lot of deep technology in chemical engineering. Okay, polyurethane paint, polyurethane. That you can get it from the nature also. You can extract it from the petroleum also. Clear?
The convection, you know what I told you. Okay. You see the butt stop in below the temperature, the water density decreases, and the cloud formation you know very well. Now what is radiation? You are having a energy in the higher level, you are living there. Again you come down, lower energy, then you will get the extra energy, no? So you have to, when jumping down to higher energy to lower energy, you will radiate something, the light, you will radiate the light. That is radiation. All bodies radiate thermal energy. This radiation is electromagnetic wave.
Electromagnetic wave have a dual phenomena with the light also, because it is acting 90 degrees with the direction of the wave and the force acting on the wave, okay, in 3 dimensions. In second level we will discuss about that the intensity of the radiation from the surface is 1 per square meter. We are emitting X-rays, okay? We are emitting photolight. The photosynthesis plate, we are emitting light from there. Photodiode emitting light from there. With that we are making some, and we make display board. Black body you will understand in higher level of level 3 of the function code. It is a very black hole in the sky, you know, you understand the ozone layer and black hole. It are threat or protector also for our earth.
The solar radiation, the black body radiation varies with the absolute temperature, and where this row is this, and the sun radiates about 50 megawatts per square meter. It is not required, but we have to keep it for general knowledge. Radiation including what? Try to understand the concept of level 1. Level 2 will define all better. But as the total course of physics, it will take not more than 30 hours of level 1, 30 hours for level 2, 30 hours for level 3, total 90 hours is over. It's quite enough to complete to get a higher rank in IIT. It is worthless to complete the 11-12 course in the end of the 12th class. Then what you will get? You should have the gift. In 9-10 you will get a little bit about that information in your book. That the concept clear so that you can do the mock test in better way in the classroom to also all the subjects.